video tutorial, I'm going to go through Spark SQL. So earlier we saw 3 Spark SQL codes. So the first one is the Spark SQL reading from a Hive table. So this is based on one of the previous tutorials where we wrote some data to a Parquet file from SparkJob, and we created a Hive table over that Spark data. Now in this tutorial we're going to read from that Spark table, from that Hive table, from a SparkJob using Spark SQL. So here, because we are running in a local mode, you need to be able to connect to the Thrift server. So Hive uses a meta store. So by default, I think it uses a Derby database. You can change that to a MySQL database. So in industrial strength applications, you'll be using MySQL. And here, if you look at the etc hive.conf hivesite.xml file, you can see the hive.metastore.uris, and that will have Thrift protocol, and path is quickstart.cloudera, and will be running on 9083. So the meta store is where it stores all the database names, table names, and so on. So Hive stores all this information in the meta store. So to be able to access a database or a table from the SparkJob, we need to first set the system property, the hive.metastore.uris, using the Thrift protocol, quickstart.cloudera.9083. Now I'm running this SparkJob in the local mode. The asterisk means multiple threads. You can put 1, 2, or whatever you like. Then we are creating a Spark context, then SQL context. So one more thing before I go is, in the pom.xml file, you need to have the Spark SQL and Hive in the dependencies. So you need those jar files to be able to work with Spark and Hive. So here we got org-apache.spark, Spark SQL, and also we got Spark Hive. Create the context, and then all you have to do is from the data frame, you do select star from, learn.hadoop is the database, and Parquet order is the table we created earlier. And then that creates a data frame. And on the data frame, if you do show, it will show you the data and the column names at the top. Then you can create a Java RDD from the data frame by calling Java RDD method. And then I can do for each, and I can get a column called order name and just print those columns, and then close this Java Spark context.close. So if I go into Hue, you can see the Parquet order table here. So under tables, learn Hadoop database. So if you look under Hive tables, so under tables, under learn Hadoop, and you can see a table called Parquet order. So this is where we're going to do select star from. So if I go in here, query editor, and then do Hive, and if I do select star from Parquet order, I don't have to prefix it with learn Hadoop because it's already on that particular database. So if I do select star from Parquet order, you will see 3 entries that are there. So it will be reading, basically running a MapReduce or a SparkJob under the covers, and it will be going to those location where the Parquet files are stored, and it will be reading it and it will displaying it. So it's an SQL interface to read. See 1, 2, 3, John, 4, 5, 6, Peter. Now here we have written a code so that we can use Spark SQL to read from this Hive table. So if I run this, so select this, read from Parquet, read from, here it is, read Spark SQL, read from Hive table, run as Java application. So there are a couple of things. Sometimes it complains about /temp hive, it doesn't have access to it. So I've already specified you may have to do run the access command. So you can give access to that particular folder by running sudo command. So you do sudo change mode recursively, give a 77 permission to this folder temp hive, so if it complains about access issue. So this was basically discussed in the step-by-step tutorial, so you can follow that. So it's still running, and you should be able to see these two lines printed. So it will be printing the df.show and also the system.out.println. So let me maximize this. See here, you can see trying to connect to Metastore Thrift on the Quick Start Cloudera 9083. Then it says connected to the Metastore. So this is where it's going to the SQL Derby database, trying to look for the objects that is Hadoop, learn Hadoop, which is a database name, .parquet order from the server, and then it uses the underlying file to go and retrieve the data from. So the job has finished now. So if you go scroll up, so you can see John, Peter, Samuel. That's the one we are printing one by one. System.out.println X, which is this row, and from the row we are only getting the order name. So that is what is printed here, John, Peter and Samuel. And this one prints order ID and order name 123 John, 456 Peter, 789 Samuel, which is the table select star from order. So this is very similar to what you see here, 123 John, 456 Peter, 789 Samuel. So in the next tutorial, let's see how we can write to Parquet from a Java file. So we'll be writing to a new folder, and it is called new orders. So write to Parquet using Spark SQL. So there's create a Spark con first, you give it a name, running in local mode. We need to put the cryo serializer, which is more efficient than the default Java serializer. Then create a Spark context here, SQL context, and then we are creating hard coding two values, order 123 John. So this is the order object. It has an order ID and the order name. It's just a plain Purger. I might as well have written this outside as a Purger, but to keep it simple, I just put it inside this class. So we create three objects, 123 John, 456 Peter, 799 Samuel, and I'm going to parallelize it, create a Java RDD, then do SQL context.create data frame and pass the order class and the Java RDD. So you got the data frame, and then you say which path you want to write it to. So I want to write it to user Cloudera Parquet new orders, then coalesce to one, write, then option compression snappy. So I'm going snappy compression algorithm, and all you have to do is do .parquet. So it'll write it as a Parquet file to this HDFS path, which is this, and then you close it. So before I can run this again, I have to go and delete this because I have already returned to this folder. So I go in here, select files. So it brings in the file. It's under Cloudera, under Parquet, and it's called the new orders. So under Parquet here, and it's called new orders. I'm going to delete them, and I'm going to go here and just run this job. So it's called write Parquet using Spark SQL. So it's called write Parquet using Spark SQL. So run this job and open the console. The console opens here, and then after the job is finished, we can go and have a look at, there should be a new orders folder created, and under that folders there will be a few metadata files, and there will be a Parquet file. In this case, the Parquet file will be a gzip file. So if you click on it, and you won't be able to view it, but then in the next tutorial we will see how we can use Spark SQL to read this file. So if I refresh this, and I can see if it has already written it. So if it hasn't, the job will be still running. Okay, the job has finished running, so it should be there in the folder. So it's refreshing it. Here we go, the new orders. So under new orders, you can see this metadata. So Parquet keeps all the metadata here, and this is a zip file. So even if you click on it, you won't be able to view anything here. So in the next here, now I'm going to read from a Parquet file. So read using Spark SQL, which is straightforward. Create a Spark conf. I'm setting this Spark name as Spark Simple. I could have even written it as read from Parquet using Spark SQL or whatever. Running it in local mode, setting the serializers, creating the Java Spark context, determining which path to read from. So it's going to be new orders under user, Cloudera, Parquet new orders. This is a name node, URI, this is the host name and port number. Creating a SQL context and passing the Java Spark context to it, creating a data frame and say here read, and then say it's Parquet. So before we said write and Parquet, see write, added some additional option, and then it says Parquet. Now it says read, and we say Parquet and HDFS. DF show will show you what's in the data frame, so which is the in-memory representation of what's in the table, so columnar format. And you can create a Java RDD from the data frame, and I can do for each and output the whatever the value that's in the data frame. So let me run this, and we should be able to see what it prints out. So this is read from Parquet using Spark SQL. So this is going to now read whatever we have written here. So basically it's reading this particular file. So even though we say new orders, you provide path orders. So if you had 10, 20 or 30 files here, you still put new orders as thing, all of them will be read. So everything under that particular directory of new orders, all the files. So you can have multiple files under here and can be read. It's not a good idea to create too many small files like that, because the HDFS is really meant for larger files. The default block size is about 64 or 128 MB. So it's good to have files larger. So that's why you try to coalesce and try to create 54 MB files. Alternatively, if you have multiple small files, you can alleviate the small files problem. Like you can have another job that reads all these and then coalesce into one, and then combine them and write it as one Parquet file, and then delete all the other Parquet files, so part files. So over a period of time, you can have another job that runs continuously and look for files that are very small, and then combine them and read and rewrite to the HDFS. So let's go and have a look if it has finished the job. Yes, it has finished running. So just scroll up for any errors. See, here we go, 1 2 3 John, 4 5 6 Peter, 7 8 9 Samuel. This is the one that is coming from this system.out.println is printing X, which is the data frame. And here data frame show will show you in a tabular format the column names and the thing. So order ID, order name. So 1 2 3 4 5 6 7 8 9 John, Peter, Samuel. So the Spark SQL is very handy. So this is only the tip of the iceberg. So Spark SQL, you can have 2 data frames created, and then you can join them. You can do left outer join, inner join, like the way you do it in SQL. You can do group by. So you can do different operations with the Spark SQL. So it gives you like SQL like syntax. You can put where close to it, you can filter it, and so on. So in the next set of tutorials, we will look at Spark streaming.